Thank you so much. Oh, just let the robot finish. Really excited and happy to be able to conduct this webinar with my colleague Darius, who I'll let introduce himself in a few moments. A brief background to myself. My name is Chris Thomson. I'm the head of sales and marketing at Flybotix. I've been with the company for around 6 weeks, so relatively new, hence my main man Darius, who's with me in case anything gets too technical, because I'm still obviously learning on the go. But really excited to be at the company, another Swiss drone company that's revolutionizing technology for different type of applications, but notably for safety and return on investment and money and time savings in different applications. And that's really the aim today, is to show you a bit as to what the solution can offer, particularly in your uses and maybe things that you've never even thought about. I have, over the 6 weeks, learned that there's wonderful and amazing things that can be done with this technology. You may know me from a few years ago. I did a presentation internally to the labs when I was working at Sensefly as their head of sales. So I did 10 years at Sensefly, who specialize in fixed-wing drones for mapping purposes. So kind of the other end of the spectrum, fully autonomous, GPS-based outdoor, whereas this is obviously confined space, no GPS, completely different applications. But like I said, part of another exciting and revolutionary Swiss technology company, and really happy to be able to present today what we have on offer, and if it's applicable, then that will be really an added bonus. So I'm also here with my colleague Darius Merk, who manages the Asia Pacific region for me, but is got the caps of many different people at the organization, and is one of the most skilled people we have at the organization. So it's a real pleasure to have him here. So Darius, I'll let you introduce yourself.
Thank you, Chris. Hello, everyone. It's a pleasure to be able to do this with you guys. As Chris said, my name is Darius Merk. I've been working for Flybotix for around 3 years, almost 3 years, and basically seen everything you can see about the drone, the different situations we can use the drone in, how to exploit the drone in the best possible way. So I've encountered firsthand what we really can do with this drone. And there are a lot of applications that are amazing, as Chris mentioned. I've flown the drone in sewers, tanks, chimneys, pipes, broken down buildings, anything that's confined space that's dangerous, you name it, we can fly it. So I'll be there for all your technical questions after. As Chris mentioned, I will also be showing some of the data that I've collected over time. Not too much stuff to not make it too boring, but I'll show you guys a couple examples of what you can expect to obtain with the drone. And of course, any questions you have, no matter how broad they are, I'll try and answer to my best. And yeah, look forward to this.
Cool. Thank you very much, Darius. So there's a brief overview of the two of us. The webinar, as we've mentioned, is going to go into not too much depth. It's really to give you a good overview of what the technology is, what the solution is, what it can provide you, and importantly, which applications you can potentially use the technology in. I'm sure there will be a few that will be interesting and applicable for many of the labs. So let's kick things off. So an interesting stat to start with, I always like to start with this stat, is that over 2 million workers that enter confined spaces annually, 2 workers die every week in accidents related to confined space inspections, which is a really wow and horrible kind of fact to know that even in this day and age, with all the advancements in technologies, that there are still scenarios where humans are being put into situations which can lead to death or serious injury. And that's a stat which we often remind ourselves of, knowing that our technology is there designed to replace those people and hopefully at one point completely alleviate and remove any risk involved and ultimately deaths to humans when it comes to confined space drones. So we are what we hope with our technology, not just hardware but software. We really are looking to provide an end-to-end solution in terms of data capture, analysis, and reporting for our users, which is a combination, as I said, of hardware, AI, and cloud-based software. Ultimately, what we aim to do is provides not only the replacement of humans to alleviate the injury or death factor, but also it's to be able to inspect faster. So for different applications, you can obviously save money using drone technology, increase productivity, so you can do more inspection in that space of time as well. And the ROIs, which I always focused on at SenseFly, and we do so also at Flybotix, it's money saved. We all want to save money for sure. Time saved, absolutely. That's imperative for most industries. But most importantly, and like we've hit upon, it's safety safe. So if you're able to replace those scenarios where anyone can be put in danger, that really is in itself worth priceless. So you can't put a price onto that. So our technology, in a nutshell. Oh, sorry. It's just the screen is bothering me slightly. There we go. So in terms of our technology, what are we? We're a complementary or hybrid mix between a conventional helicopter, which you all know, and a classic quadcopter. I know the quadcopters for the labs, given the work you do, will be familiar with DJIs or Parrot or Autel or any of the traditional commercial quads that are on the market. They're obviously 4 propellers above. Helicopter is 2 propeller. We're a mix of the two. We're taking the 2 propeller of the helicopter, as you can see there, but we have a propeller on the top and on the bottom. And you'll see later in the presentation, this is particularly important, and a patented technology exclusive to Flybotix, which essentially allows the flight time to be enhanced because of the propulsion system. So if you look at propulsion systems for conventional methods, it works for sure. It's been working for over 100 years, but absolutely there's certain things that can evolve and iterations come into play, and our propulsion system is one of them, which allows us to keep a lightweight system, but also to add weight if needed, but really to optimize the ability to increase autonomy. So compared to our competition, we're more than double the flight time to what you can expect on any other confined space drone. And that really is an important factor, especially when you're looking to inspect in stressful situations where you don't want to be rushed and where you really need to compose yourself, and added time really is a luxury that you would want to have. So the drone itself, as you can see here, it's a drone in a cage. If we want to keep it in a nutshell. First of all, the propulsion system, as I said there, it's a counter rotating, so that's also an aspect to the way in which we're able to maximize flight time. A technology, as I said, that's patented and allows us to push our flight time up to 24 minutes. And as I say, competitors close to us with similar designs or similar concepts are flying between 8 to 12 minutes. So you're really doubling the flight time that you can't see on any of the competition. Lighting obviously is key, predominantly where our clients or users are using the system tend to be dark areas, whether that's sewers or tanks or any confined space by definition lacks luminosity. So lighting is a key factor. So we have high intensity oblique lighting, which improves the vision, and obviously more importantly improves the ability to capture the data in dark or dusty again, which is a frequent environment that our users map in, allowing for better visual data. And then also, as we know, in terms of photogrammetry, if you're using the individual photos to try and reconstruct things in terms of a point cloud, it enhances or increases the ability to be able to do that. The main payload, the star of the show that's in the middle there, it's a dual sensor. It's 4K video and a radiometric infrared camera with 180 degrees unrestricted vertical field of view. So obviously you can maneuver the drone. It's on the gimbal. You can look up, you can look down, which is important. Again, for different types, if you're in a tank, you need to see the roof of the tank and the bottom, and the only way to do that is to have the camera on the gimbal. Radiometric infrared that allows you on the software to isolate spots or areas of interest to see what the temperature is. Again, we can all get creative and to think how that could be useful and applicable, but in nuclear or energy, temperature has an impact. Underground mining as well. These are areas and market sectors which is important to know and to safely be able to highlight what type of temperature is in these facilities. A collision-proof cage. So this again is extremely important. It depends really on the inspection job you're doing, but you could very easily be seeing the drone and flying it. Let's say in a sewer, you could be in the sewer, you could see the drone, but very easily as well when it comes to confined spaces, the drone is moving away from the field of view, from the eyesight of the operator, and so to be perfect when the drone is not in your eyesight is somewhat difficult or not even impossible. So we have the cage there to be able to protect both the drone itself, but also the user in case he bounces into, say, the walls of an infrastructure. So it's designed to be able to take that impact. Obviously, we're not teaching our users to go full pellet gun kamikaze into the side of infrastructure. But as I say, the design of the drone, you can see there the triangulation design. It's obviously closely linked to architecture and the strongest way and the materials we use to maximize the durability, but also to keep it lightweight. So the cage itself is extremely important in the overall design and ultimate use from our users. Infrared optical sensors, algorithms. So these are all obviously important when it comes to flights in GPS denied conditions. We're all again used to pretty safe and drones that behave pretty much as we would expect when it comes to fully autonomous GPS-based drones, such as the EB or again any outdoor mapping drone. When you remove the GPS ability, obviously then things can become difficult. So that's why we have different sensors to be able to assist the user, but especially the drone, in being able to keep it stable in all types of environments. And this technology evolves, and we take all the feedback from our users, because again we see wonderful and new ways in which the drone has been used in different environments. So this all goes into our R&D and our future roadmaps to be able to continuously help stabilize the drone in these environments, because as I said, GPS denied environments is completely different to the drones you're used to, and that's an important factor to understand going into this technology, that it's not as plug and play as a sense like EB. You draw a map and it does its thing. There are you do need a good pilot, you do need good training, and you do need to have the technology that helps the users in being able to operate the drone as efficiently as possible. And then the smart battery, obviously, this is probably not new to anyone. We take all the learnings that have been done over the years in the drone industry in terms of how to optimize the battery in being able to maximize the use. And as I say, that's also interlinked to the 24-minute flight time that allows us to push it to the limits compared to other technologies. So that's the drone in a nutshell, and in what's offered in hardware standpoint. Pilot assist. So as I said, the important factor for us as a company when it comes to allowing our users to have as easy as possible when it comes to being able to operate in any type of scenario, but especially these difficult confined spaces, means that we have all of the technology that's meant to enhance and assist when it comes to keeping the drone stable. There's other things which you may have been familiar with again on some drones. SenseFly also, back when we did a quadcopter, had these type of features, so it's there to be able to add an additional layer of assistance to the users when they're using the drone. So let's put ourselves in an example of an inspection we're doing. Maybe we're in a sewer or an underground mine, and we want to map the facade. Particularly important there, especially for getting the data from where you want to get it from. You want the drone to be as stable as possible. You don't want to be stressing or worrying too much about, is the drone pushing towards the wall? Is it going to the roof? Is it going down? Is it going left? So the aim here is that once you're sure that you're in the area or the vicinity of the infrastructure or the facade that you want to map, then you can enable these pilot assist features, which then, as you can see there, locks the drone either altitude, roof, ground, vertical, wall, all type of different features using the cameras and the assist features on the drone's hardware to be able to behave with the environment, to then lock itself in and then reduce the worry factor of having to think about literally everything when it comes to operating the drone. You can then focus on the data or understanding the data or moving the drone to left or right instead of up and down. So these are really important features which are interlinked into the technology. Repulsion. I don't remember what repulsion is, Darius. Can you quickly remind me what repulsion is?
Repulsion uses all the infrared distance sensors around the drone to
Yes.
move away from obstacles if they are detected. So these sensors are quite directional, so it's not a guarantee of no collision, but it's an assistance. If, for example, your drone is going to the side and you haven't seen there's a wall on the side, then there are two sensors looking slightly to the side. When they see this and when it goes within a certain distance you've preset, then the drone will move away from that wall.
Exactly. Perfect. Couldn't put it better myself. Thank you, Darius. So again, a very important feature. Again, as you say, you're focusing on the facade in question. You're moving left or right, as Darius says. There could be an obstacle or a wall or something there, and portions there. Again, not a complete fail-safe, but it's designed to be able to assist and remove again another factor that you should have to worry about. Rewind again is an important one. Radio range again is another thing we didn't talk a bit about in the hardware, but radio range and the link between the radio and the drone is particularly important when it comes to these type of drones. So should the drone lose the radio connection or link with the user, the drone can then rewind 10 meters from its previous flight, meaning it will, to the best of its degree, move back 10 meters or the exact way in which the drone flew, back those 10 meters in the hope, and more than likely, and most times it does, it regains the radio connection, and then you can bring the drone back or continue the inspection. Auto lands kind of says what it is. It's an auto landing of the drone. And recovery is for any reason, if the drone is on the ground, not in the air, but on the ground, and it flips over, it's kind of a turtle mode. It will flip itself and position itself back the correct way it should be. So again, all these features designed over many years of R&D and customer feedback to try and optimize and maximize the ability for the user to perform inspections to the best of their abilities. So we talked about ROI. This really focuses on return on investment in the monetary sense, but it's a good slide to give you an indication of the type of groups that are working with our technology, the type of projects that they're doing, and especially importantly, because you guys are like a business, and to be able to save money, whether for an organization or a government or a project, or ultimately being able to use a technology that then allows you to save this money, which you can spend on other things, is an important factor to understand. So you can see for wind turbines, again, wind turbine or renewable energies is a huge technology and a huge market sector which continues to evolve globally. We have oil tank refinery inspection. This is, again, oil and gas is a huge part. 6 million savings a year. Obviously, this is huge. Maybe not so big for oil and gas, but let's just talk about tanks in general. It could be an oil tank, it can be a water tank, it can be a chemical tank. Any type of tank is dangerous for a number of reasons, whether it's because of the liquid or chemical that's inside the tank, or because it's too big to send humans in, or they have to climb ladders in pitch black, and we can all appreciate what can happen there. So money is huge there, but I definitely think for tanks in general, the safety aspect is a big one as well. Ship inspection, again, huge part of the way in which our economy works and the ability to be the world which we're in, with tanks, ship tanks going all over the world every single day, and they need to be regularly inspected like most critical infrastructure. And that's again where drones can do it safely, but can optimize the ability to do that. So maybe it's less time of a ship in the dock, which again saves them money, but allows that merchandise or food or important resource to be delivered quicker than would have been otherwise. Water is a big one, and that's one we have kind of a separate slide on just to talk a bit more about that. So I'll go into that afterwards. And renewable energy, so hydroelectricity, so power plant inspection or dams, pen stocks of dams is also extremely expensive to inspect. It's an inspection that needs to be regularly done, and it's because of the way that they're built. It's very dangerous environments for putting human-based inspections in place. So Suez is important, and it's an interesting one to focus on because twofold. I believe this is a very universal or applicable user case for all of the labs. Everywhere has sewers, that's for sure. They all need to be inspected. And I think I read that London only now, after 100 years, is starting to have its sewers inspected, and there's just tons of it to be inspected. And so drones are being used across the capital in the UK to be able to these inspections. And also smart cities, or as we build cities. And again, I think this is a particular point in case for the flying labs and for developing parts of the world where we start to increase cities and develop infrastructure and try to become a certain standardized quality and have infrastructure in place. And sewers is usually the number one thing that you'd want in a city to be able to function well. You don't want to have a city that doesn't have a proper sewage system. So that's why I wanted to focus on this as a really important and probably very applicable case for all of the labs. And why is it important or applicable for us at Flybotix? Well, it goes back to that 24-minute flight time. What we do best is obviously linear or corridor based mapping, which is, as you can usually tell, is sewers. And so it's important to have that maximized flight time compared to the competition. It allows to maximize the inspection of those sewer systems. The way in which our camera works is optimized for that linear kind of infrastructure inspection. So I think this is a really interesting one, and I think Darius will give a bit of data linked to this particular case after the presentation. So that's why I really wanted to just focus on why this could be an interesting and important inspection application for the labs. But like I say, there's tons of other things. If you do invest in this technology for, say, sewer inspections, it's not then you've just got a drone for sewers inspections. You've got it for tanks and chemical plants and as Darius said at the beginning of the presentation, anything which requires confined space or dangerous areas where you don't want to send people in, you have the tools to do it with our drone. So a few other cases there. Again, you can see, as Darius says, he's done himself, flown, and this might even be photos of him flying. He's done chimneys, he's done chemical plants, furnaces for energy productions. Again, as I said, I've only been at the organization for 6 weeks, but I'm already just every day learning of a new potential application for confined space drones, which before joining Flybotix, I thought I 10 years at SenseFly, I thought, it's the coolest drone on the market, great technology. But realistically, now that I see how many applications this can touch and how much it can improve the safety aspects globally speaking, it's really interesting to be on this journey with Flybotix. So as I said before, we have not just the hardware. We've gone through the drone. It's a 24-minute cage drone. We know that. We have the ASIO flight controller, so we didn't see that visually, but here it is. That's the flight controller which you will use to pilot the drone. This can also be connected via cable to an external screen, so that, so let's say you're two people. One is the pilot and he's focusing on the job. The other person is more focusing potentially on the inspection part, the visualization during the flight of, say, cracks or rust or what needs to be viewed. So that can be enhanced and obviously increased in size on a separate screen, so that the inspector can have a better visual application when it comes to the part of the flight. And then the ASIO Explore, which is the post processing. So again, we're all very familiar with post-processing, whether it's Pix4D or Agisoft or any type of software which takes the images, takes the data and reconstructs it. This is our internal software, which again is evolving, and we're working as much internally from our R&D on the software as we are on the hardware, and that's important. And that goes back into the message I was saying in why we focus on a solution and not just the hardware, that we are looking to bring the full solution in terms of the software part. So we're looking to add AI for automatic detection of, say, cracks, that give you the automatic length or the width of cracks or defects, to be able to quickly assess whether that needs to be taken action, or for your report for say the local government. I don't know what, but again, the addition of AI to automate and assist even in the assessment of the data is important. So the post-processing software, as you can see here, this is a 3D point cloud, which I'm sure we all know, which you can localize points of interest for future reference. The thermal, we talked about that before, where we can isolate a spot to be able to have the temperature or the difference in temperature. Again, particularly useful in numerous applications. And then obviously data which is compatible with photogrammetry software. So that's probably one of the questions that would come up. You had your post-processing software. Can I use the data from the drone and other post-processing software? The answer, of course, is yes. We want to have a full solution for our clients, and we are continuously improving that software in relation to the applications that our users are doing. So let's say Pix4D is generically a post-processing software for all types of photogrammetry or GPS-based photos, whereas we're really looking to put our software as an expert kind of post-processing software in its abilities and functionalities to be able to allow the user to maximize his efforts and to get the most out of the reporting. Because this whole flow, this whole use of hardware and the job itself, then the post-processing, it's all really because you need to get a report, you need to understand something, and that's why we're trying to obviously enhance and optimize that part of it as well. So that is our product stroke solution in a nutshell. As I said, I wasn't going to go too complex. I hope I summarized and did a good overview of what we offer and where it can be used. And so now I think it's good to go back to the point of the sewer inspection and have Darius show you. We've done all this. What data have we acquired, and what does it look like?
All right. Well, maybe some people have questions before that, or do we want to just jump into just showing some data right away? What do you want to do?
I think it's good to finish the presentation so they have everything to hand for you
Okay.
to show the data, and then we'll do Q&A. If that's okay with you, Kaja?
That's perfect.
All right.
Okay, so let me try and Chris, you have to disable your screen share, or whoever's, yeah, you.
Thank you.
Thank you. And select, there we go. Allow. Okay, are you seeing my screen?
Yeah, all good.
Okay, great. So that's a very recent example. It might be a little laggy. That's due to my internet connection. But that's a recent example of flight in a sewer. So what you see here is what you actually might recognize from Chris's presentation. You have your actual RGB image and this is the image that the pilot uses to fly the drone. So this is literally what we see on the screen of the controller. Now, this, of course, is recorded on board the drone. It's also next to the infrared that we can visualize as well. And then once we have finished our flight and we've gathered the images, we can then create a point cloud. Now, it's going to work in situations like this. We're going to be able to generate a 3D map that will allow us to then pinpoint the defects that we find, for example, if we're looking for defects. It can be defects, it can be just an assessment of the general state of the sewer. Many inspections I've flown, people's requirements were actually just to visualize the state of the sewer or the asset they have without needing to send someone inside. So this mapping process is not always required when we fly, but sometimes people want to have a map to be able to say, okay, this defect is here. For example, if I click on these, what we call points of interest, I can see the image that I can capture with my controller in flight. So I can be flying through the sewer, and all of a sudden I can say, hey, this point's interesting. Or most of the time I'll have an inspector with me who's going to say, this point's interesting, take a picture of this. Now, once I took a picture of this, then I can actually visualize it like this. So you might notice on the bottom here, you see a little number 1, and this number 1 is the location in the timeline of the point of interest. So by point of interest, I mean it's an image that we captured. Okay, so this is cool to have it on the timeline indeed, but what's cooler is after you build a 3D map, so you would go in here, 3D map, you would start a new session, you would start beginning and end, and then you would generate this 3D map by SLAM processing. The way it works is not that important, but basically it looks at images one after the other, and it finds features that it sees in successive frames, and then builds this map that you see here. So I can remove, well, I can scooch this here. There we go. So what you see here is just a simple reconstruction of this flight here. So you might see over here on the bottom next to the 0, a little yellow cone, which I will actually make larger. There we go. So now it's much larger. You see this little yellow cone, and this is actually the drone's position. So you see here, my drone is moving in the environment. And you see it, and you see the 3D model point number 1. It's a little small. I can't see it, trust me. There's number 1. So this tells me not only where point number 1 was taken on the timeline, but also allows me to say, for example, I can measure the distance to point number 1 and tell the inspector or the person who's going to be using this data, well, the distance between your starting position and this point number 1 is X meters. Now, of course, the accuracy of this is not perfect, but it allows us to give them a very good idea of how far in the defect is. As you see here, I just measured the distance between the entrance point and the, so I'm just going to let this run. So we see the drone moving. The entrance point and the end point here, where I turned the drone around and back. So yeah, you see here the video, you see the water flowing and all. Of course, the drone is still moving in this environment. So this is a tip sewer. This is kind of a easy sewer. What I'm going to show you now is perhaps a slightly more fun sewer. Let's see, this one. There we go. This is another example of a sewer, and this one had a lot of features to actually look at that were really interesting. Again, you'll notice the different pictures here. So let's say picture number 1 here, picture number 2, 3, and so on. And in these pictures, what I didn't mention before is that you can zoom. So there you go. you can zoom into the image and you can actually have a close-up look at the asset you're inspecting. Now, bear in mind that this is pitch black when we're looking, so this is just the lighting of the drone. There we go, that's another part of it. You can zoom in and you can see. This is a pipe that's very rusty. This, I have no idea what it was. Well, a water entrance over here. And all these features, you can actually see them very well if you look on the map. So you see here, my drone's position. This is image number 4. You may be able to see point number 4 here. There you go. And it shows me where this point is on my map. So what I can do is then, again, I can say, for example, okay, I want to know how far it is from my entrance point. So this is roughly my entrance point. This is where I started. And so if I want to measure from here to know where it is, then I can just switch to my measurement mode, go from here to here, and I get a rough idea of how far I am. There we go, 58.11 meters. I'd say, to the person, I'd say roughly 58, 59, whatever meters. We see there's a little curvature, so it might be a little longer. But yeah, so this is what we can do with this. I can actually show you more of the footage. There we go. This is actually flying in that environment. So you see what you can obtain there. And during this whole inspection, there's no one that needs to go downstairs. Downstairs. There's no one that needs to go in the sewer. Everyone's on the street, and we have an antenna that's inside the environment. And this antenna is allowing us to communicate with the drone. So this means that it's safe for everyone outside, as you might actually be able to see in the beginning of the video. There you go. In the beginning of the video, you see the antenna here, the long extender, and you see the people outside. And so we're outside here, and no one has to go inside this environment. This applies for all the situations, all the inspections we could do. Chris has shown ships, mines, tanks, all this. We never need to actually enter the environment to be able to do this sort of inspection. One other one I just wanted to show you before I leave the floor to you guys is building. This was a pretty cool example, actually, in a broken up building used for training. There we go. So you see the type of environments in which the drone can navigate. It can be damaged buildings like this. We can easily fly in there and not worry too much about having the drone actually crash into obstacles and break, because it's protected by the actual roughly 80 centimeters wide or so, and we're still able to navigate. And let me move a little more. There we go. So you see typical collapsed building situation where you would want to assess the situation for sending proper footage of how it looks, and professionals can assess whether it's safe to go in or not. We can again do some sort of a map of the environment, and we can a view, let's say here a top view. So you see my drone moving here again, and I see the different rooms of the building in which the drone is evolving. So you can also use this to, for example, locate someone if someone was stuck in that environment. And you can in search and rescue as well, not only in actual inspections, but also search and rescue applications. I think I've shown enough data now, so I'm going to give the floor to whoever has questions. And perhaps, Kaya, you can take it from here.
Sure. Thank you both. It's a I will just put you on mute, Darius, because I can hear my voice. But I saw already we have a few questions in the chat. So let me just scroll up. So the first question was from Senegal Flying Labs, who was asking whether you can speak French and if you have any documentation in French. And I think it's in relation to the support that you can provide to the team.
I mean, Darius is mother tongue French, even though he sounds maybe American. I can also speak French, even though I sound like a very British person. But no, as a French part of Switzerland, the organization has obviously a lot of people speaking French, and so our technical support is in French. Documentation, Darius, do we have all of our stuff in French or not?
No, but with today's technologies, it's not too complicated to translate.
And more importantly, I think the most important thing, if you were to invest in the technology, is the training, and the training would be able to be in French. So that's an important point to know.
Great, thank you. The second question is from Ku from Malaysia Flying Labs, who is asking, can the drone be utilized to fly under a tree canopy, which is partly confined space? I assume that the drone will have anti-collision features. I know this has been partially covered in the presentation, maybe after this question was asked, but maybe we can just do a quick summary once again.
Chris, you want to take that, or you want me to?
Please.
Okay, so really there's no limitation in the kind of environments we can fly. The more confined, actually, the better for the drone, because as Chris mentioned during his presentation, the drone relies on sensors for its stabilization indoors, since it doesn't have GPS. So when you have lots of features around the drone, it works best. The only limitation I could think of, if you're talking of a tree canopy, is just wind. When we're flying outdoors, we do have a wind limitation. So that's the only thing I would take into account. Now, depending on how many branches and all you have laying around, then it's more or less difficult. But yes, you can use the drone to fly in these environments as well.
Thank you, guys. The next question is from Diana from Zimbabwe Flying Labs, who says, thank you for the presentation. What is the cost of the units and what training do you provide?
Very good question. So the cost of the system, normal end user price is around $32,000, which is about 45%, 50% cheaper than the next similar product in which does the similar thing in terms of the confined space drones. However, we also do have, like we always did in the past at SenseFly, discounts which we provide for non-governmental, educational, that type of thing. So I think best way to get an idea, especially with the training, because training, we have training in our offices, we have training where we can come sur place for people to have training in their vicinity. So I think it's best, if you are interested, to get a full price with the discount and with the training. Kaja, you can leave my email address with everyone, and I can provide tailored quotes, I guess is the best.
Perfect. That sounds great. And I think your email address was at the end of the presentation, if I remember correctly.
Cool.
If not, all of you can also reach out to me, and I will be more than happy to connect you as well with Chris and Darius. The next question was from Tina from Uganda Flying Labs, who is asking if the drone can be used to fly over buried underground pipes. I assume that we're talking about the like survey over the ground of underground features or elements to detect leakage and rust.
I mean, if they can't see the pipes, yeah, it doesn't have the ability to see pipes underground. So if that's the question, then no, unfortunately not. We wouldn't have any type of penetrating LiDAR kind of technology that would be able to penetrate the terrain to be able to tell if you had rust or defects on pipes on the ground.
But if the question is to actually go in these underground buried pipes, then yes, that's similar to sewers and it works as well. So it's a question of what exactly was meant here. If it's flying above ground to look through the ground into pipes, no, impossible for us as it is today. But if it's to look at buried underground pipes by flying inside them, then yes, that is possible. That's what the drone is made for.
The next question came from Kwama, but I'm not sure. I think it was linked to something we talked about in the presentation, because it says, how does the drone work in that kind of space? What about obstacle avoidance? So maybe Kwama, you could just add a little more detail. What was discussed at the time when you asked this question? What kind of space did you mean? And then we can come back to it later. Rene from Bolivia. Yeah, sorry, go ahead.
Yeah, so I saw the drone go in the sewer, and obviously it was looking really tight. And I'm thinking about obstacle avoidance because sometimes when I fly the RTK, it stresses about that. So like I'm like, how does it work? Does it have obstacle avoidance? Does it not? Or...
The pilot is your obstacle avoidance. No, there is the repulsion feature, which we mentioned, that does take into account some detection of the obstacles using the infrared sensors. However, this is limited to the actual field of view of these sensors, which is quite small because they're very directional sensors. You just imagine lasers going out and coming back and then measuring distance from there. So if it's like a tube or something, then yes, you can use that and it will help. Otherwise, you cannot rely on autonomous flight, doing autonomous obstacle avoidance in that environment. The pilot is responsible for avoiding obstacles when you're flying in sewers, but it's feasible, trust me.
And again, back to the point on the cage, that's important why we have the cage, because there's no perfect pilot out there. We want to maximize the features available so that should you do go into this, it's just going to kind of recoil off and you can continue your mission. So.
Right. Okay, thank you.
You're welcome.
Thanks for your question. And the last one in the chat, maybe there will be more, but the last one is from Rene from Bolivia Flying Labs, who's asking about the size of the drone and the diameter.
Roughly 40 centimeters, the diameter. And the height is slightly smaller, if I'm not mistaken. But just consider a sphere of 40 centimeters in diameter, basically. So it fits in every manhole possible. So it's if a human being can go, the drone can go.
I think we recommend that 1 meter of diameter for pipe-based projects is the limit. Once you go smaller than that, then it becomes too complicated.
Yeah, minimum pipe diameter is roughly 1 meter if we want to fly in that environment. If we're just going through a manhole, then it's fine if it's literally the size of the drone. But if we're going for a long flight in a pipe, 1 meter is accurate, as Chris said. We can fly it smaller, but it's not recommended, and it's not really flying that well because of the turbulence generated by the wind that's been pushed down from the drone.
I actually also have a question for you guys. You mentioned that you have the turtle mode. Has it ever happened to you to crash into the water underground, and is the drone waterproof? So can you turtle mode out of the water?
It has happened to crash in the water, but it's not possible to do a turtle mode underwater. We don't have the torque that quadcopters have, because quads you can just full reverse. I mean, they just flip over in any way. For us, we don't rely on torque to flip the drone around, but we have to actually generate the tilt with the props to make it flip over. It's actually really cool to see, but in water, typically it wouldn't work because the propellers wouldn't be able to spin up and give it the proper torque. And also there's one thing you mentioned in the beginning about being waterproof. The drone is not waterproof. It is resistant to drops of water. If you're flying in sewers, you shouldn't worry too much about it. Now, of course, you can't fly under a jet of water, that's a stream of water that's going through the sewer, because simply the mass of the water is just too much for the drone to actually be able to fly underneath. But it's resistant to some drops of water that would fall from the ceiling when you're flying in a very humid environment.
That's interesting. Thanks. Do we have any other questions? I see the comment from James that was probably in relation to Tina's question, who says that ultrasonic sensors may be of help in inspecting buried pipes while flying outside. It may be worth considering. Thanks, James, for sharing that. Do we have any other questions? I'm also, I just wanted to thank everybody for joining before we end the webinar, because I counted more or less how many flying labs are represented in this webinar today, and I counted 21. Possibly we have more, but that is more than half of the entire network. So thank you so much for showing up. And yeah, thanks.
Absolutely. Thank you, guys. Real honor, and hopefully the next half can see the recording when you send it through them.
Yeah, absolutely. And I see we don't have any more questions for now, so maybe we can just end a few minutes early, unless you have something else to cover, Chris and Darius.
Nothing to cover. Just wanted to reiterate my thanks for giving us the platform and the time to be able to present today. Me, on a personal note, it's great to be back in the drone industry, and great to be again working with Kaja and all the labs, because it really has a close place to my heart. So looking forward to being able to collaborate with some of you, answering any questions moving forward. And there's a lot of cool things coming out of our organization this year, so I'm sure we will reschedule another webinar in the coming months to be able to update you on the future developments of our technology. So yeah.
I'd like to also thank everyone. It's always a pleasure to be able to share our passion. Well, for me, it's definitely a passion. So I'm really happy about that. Thank you for the occasion. And also, since the sharing of the data is not really easy when it's a screen share and all, I can provide to whoever would like it the videos I have shown, so you can actually get a proper understanding of how it really looks when you have the HD video on there and you're not going through internet and another internet and all that. So whoever wants to get some data from us to see the actual recording, I will gladly share that. We can make an easy way to share so you guys can visualize it.
That would be great. And big thanks to you, Chris and Darius, for your time and for joining us today for the presentation. I would love to get the videos, and then I can share it also with the rest of the network, with those who couldn't join us today. Awesome.
Okay,
so I think we can end here. Thanks again, everyone.
Right. Thank you, guys. Have a great day, and look forward to speaking to you soon.
Right,
Thank you very much. Bye-bye.
Bye.